Hello everybody, welcome to Chapter 6.3 Part 3, Dividing Radicals. Dividing with variables. When variables are introduced into radical expressions, remember to use the rules of division when dividing variables. In example number 15, we're asked to divide x over square root of y divided by square root of x cubed. So let us go over to the whiteboard and do this one. We have x square root of y divided by x cubed, square root of x cubed. What we want to do, of course, is we want to simplify that and see if we have to rationalize the denominator. So let's see. X square root of y over, well, we have down here x squared x, so that means x square root of y over x square root of x. And what's really nice here is it turns out that the two x's cancel out and we're left with y over square root of y square root of x. And of course, as we can't leave it like that, as I said earlier in one of the earlier lectures, we have to get rid of the radical sign on the bottom, and we do that by multiplying the top and the bottom by x, so we end up with xy all over x, and that becomes our final answer. Reviewing what we just did in 15, we got x square root of y over x square root of x by taking out the perfect square in the denominator. We saw that the denominator can be simplified by doing that. We canceled out the x's that were outside because they're identical, and then we rationalized the denominator in order to get the square root of xy over x. And that's our final answer. In example number 16, we're asked to simplify the square root of 48x cubed divided by the square root of 3x. So let us go over to the whiteboard and work this one out. So we have square root of 48 x cubed divided by square root of 3x. So let's see if we could maybe make things a little bit easier by one of our tricks that we learned in an earlier lecture. So what I'm going to do is I'm going to put everything under the radical sign to see if I can simplify anything. So I have 48 x cubed over 3x. Well, it turns out indeed I can, because 3 goes into 48 16 times. So I end up with the square root of 16 x cubed, which is equal to, well, we know 16 is a perfect square. And here we have 16 is a perfect square. And also, we also see too that this x cancels out with that, leaving us with x squared. So that means we have 16x squared. So we end up with, in here, 16x squared. So now we just write, that's a perfect square, 4x, and that becomes our final answer. So we see that by putting this all under the radical sign, we can simplify the 48, and we can cancel out the x from the bottom to get this nice simple radical, which is all a perfect square, and end up with just 4x. In reviewing what we just did on the whiteboard, we saw that 3 could go into 48, so we used the quotient rule for radicals to simplify that part. And we found that not only did 3 go into 48, x also can be divided into x cubed. So we ended up with the square root of 16x squared, and we saw that those are both perfect squares because 16 square root of 16 is 4 and square root of x squared is x. In example number 17, we're asked to simplify 5x square root of 24 times 3x square root of 45 divided by square root of 6. So let us go over to the whiteboard and work this one out. For our last example, we're going to actually use a few things. So this is really just all numbers, but it's kind of has a lot of things going on. So we have 24. 5 square root of 24 times 3 square root of 45 all over the square root of 6. So what do we want to do with that? Well, let's get rid of the brackets first. So what we're going to do, let's simplify inside the brackets, inside the radical sign, and then we'll deal with the brackets. So we have 5 square root of 4 times 6, because remember we're always looking for that perfect square. And here we have 3 square root of 9 times 5, because we're always looking for that perfect square. This is all divided by the square root of 6. So now we have 5 times 2, square root of 6. And here we have 3 times 3, square root of 5, all over square root of 6. Now what's kind of really neat about what we just did is because really this is multiplication. All multiplication, we don't have any addition or subtraction in this, so we can actually do some canceling out. And it turns out we can actually cancel out the square root of 6 from here and the square root of 6 from here, which makes things a lot easier. So now we can write 5 times 2 is 10, and then times 9, square root of 5, and then, of course, 10 times 9 is 90, square root of 5. So by knowing all these different rules, you can find simpler ways of doing it. You can also rationalize the denominator and start off like that, etc. But there's also other things you can look at besides that to make things a lot easier. Reviewing what we just did in 17, we found the perfect squares underneath each of the radical, and we used that to simplify, and we saw we got a square root of 6, so we were able to cancel out the square root of 6's on the top and the bottom, and we ended up with 90 square root of 5. And this was our final answer. Thank you very much. I hope you enjoyed this video. Be well, take care, and goodbye for now.